Okay, so factorise means put an expression back into the brackets that you expanded to give the expression. It's a quadratic, it's got power 2, power 1 and power 0, highest power being 2, so we know it's going to be 2 brackets. So we know the answer is going to look like that. The only difficulty is that to get the 6x squared, this could be 3x and 2x, or this could be 6x and a single x. So we could do trial and error to get the answer. There is a method though that will go to the answer for us, and it's a method worth learning because you won't always be dealing with small numbers like 6 and 20. You could be dealing with 30x squared and so forth, which would have a lot more different combinations for these. So the method we can use is by taking the two parts of the quadratic, the 6, the coefficient of the x squared, times the constant part of the expression. So 6 times negative 20 equals negative 120. We can then do the prime factorisation of negative 120, so negative 260, 230, 215, 3, 5. And then what basically we've got to do is we've got to look at combinations of these prime factors that will add up to positive 7. So we can see hopefully straight away here that 3 times 5 is 15, and if I times those together I get take away 8, negative 8, so 15 take away 8 would give me positive 7. So the factors of negative 20 that work are 15 times negative 8. And basically that gives us positive 7, which is the middle term. So literally then I rewrite this as 6x squared plus 15x take away 8x take away 20. That's equivalent to this. And the reason I've written in this order of 15x with a 6x squared is because 15 and 6 both have a factor of 3, and 8 and 20 both have a factor of 4. So we're looking to get relationships that work between basically what we're thinking of is this bit first and then this bit second. So what we do is we factorise this part fully. So the highest common factor of 6x squared and 15x is 3x. 3x times 2x will give us 6x squared, and 3x times 5 will give us 15x. Whatever this part is, you then write that again, so that gets repeated here, and then we'll look for what we multiply this by to give us, so we'd have to multiply by 4, and negative 4 of course. So negative 4 times 2x gives me negative 8x, and negative 4 times 5 gives me negative 20. So our answer is 6x squared plus 7x take away 20 is equivalent to the bracket that we have as a factor of both halves of the rearranged factorisation equivalent, and 3x and take away 4, the coefficients of the bracket go in a single bracket to make that. So 3x take away 4 times 2x plus 5, and we can check it by doing our cross multiplication. So 3x times 2x is 6x squared, 3x times 5 is 15x, negative 4 times 2x is negative 8x, so 15x take away 8x is the 7x, and negative 4 times 5 is negative 20. So that method of multiplying the coefficient of x squared by the constant, factorising that, and finding two factors that then multiply to give you the negative 220, but then add to give us, so 15 times negative 8 gives us 120, and 15 add negative 8 gives us positive 7. So that's why that particular part worked, because the 15 plus the negative 8 gave us the positive 7 in the middle, and the 15 times the negative 8 gave us the two numbers there. And this technique always works if the quadratic does factorise. It'll even work with a single x squared if you want to do it this more complicated way, but I say this way is worth learning for higher coefficients of x squared than 1 or 2. Okay, so that's the answer.